All right, cool. I think I want to just go through. I'll end with question 5.1 now, because remember, we've already gone through that. But I want us to just prioritize question 5.2 now for now, please. And then we will look at question 5.1 as the last question. Because remember, we've already done that. I'm not saying we're not going to do it. I'm just saying let's just quickly finish off this one, question 5.2. Now, here, they say Upam, who is the sales manager at AGM, and her team discussed various strategies to improve their sales of perfume. One of these strategies is to package their perfumes using a cylindrical bottle and a rectangular bottle. The bottles will be filled to 90% capacity. So it just means that they're not going to fill them up, completely, all the way up to the brim. Okay. They're just saying they're going to fill them up to 90% capacity. Right? All right. So you need to just think about that. The picture below shows the bottles and the dimensions of the bottles. Right. Let me just fix this thing here. Right. So you're given the cylindrical bottle. It has a radius of 4 centimeters and a height, that's the height there, of 5 centimeters. Then you've got this rectangular bottle that has a length of 7 centimeters. So that is your length. Your width there of 3.5 centimeters and the height of 7 centimeters. Right. Now, question 5.2. Remember, these are just your basic questions. Okay. Why do you think the perfume bottles are not filled to its maximum capacity? They've just filled it. I'm sure you can see, if this is my perfume, they've just filled it up until maybe there. Why have they not filled it up until there? Why only stop here? Why do you think that's the reason?
To avoid spilling.
Yeah, I also said that, to avoid, an overflow, and then now it will spill. Because I mean, if you were to fill it up to 100% capacity, how will you close this? And actually, if you were to try and close it, it will actually overflow and spill. Right? Any other reason?
I think it can also leak on the lid.
Yeah, right? It can leak, okay, on the lid. Okay. Any other reason? Also, if you were to fill it up to, 100% capacity, right? Then it would be hard for the liquid to move from there all the way to there. Okay. So to allow for movement of liquid. Okay, you can even say or allow for movement of the liquid or the fluid. All right, good. Question 5.2.2 says, in 1 month, AGM storage workers packed 75 perfume bottles as cylindrical and rectangular bottles in the ratio of 2:3, okay, in a box. Determine the probability of selecting a rectangular box or rectangular bottle from the box. Right. So here, this question, it's a ratios question, right? And with ratios, if you think back to ratios, now this is like grade 9, and they say that, apples were shared. Maybe they say there's Utabo and Ntabiseng, okay? Ntabo and Ntabiseng share apples in the ratio of 2:5. Please, I'm just making an alternative example. Actually, let me just move down. They saying Tabo and Ntabiseng share apples in a box in the ratio of 2:5. They are sharing. Okay? Now, they tell us that there's a total of, let me try to give you a proper number that's not going to give me decimals. There's a total of, let's say, 35 apples. I hope it doesn't give me decimals, but anyway, if it does, it is what it is. There's a total of 35 apples, in this, box that has, this box. And now, Untabi and who did I say? Tabo and Time want to share these apples in the ratio of 2:5. Before we get to the sharing, okay, and they've given you a ratio, you first need to determine what is the total for this ratio. So from what's given to us here, get the total. So when you take 2 plus 5,
It's 7.
you get 7. So that's the total, okay? So that means that, let's say, for example, the 2 represents the apples that Nthabi is going to get. The 5 represents the apples that Tabo is going to get. Now, for us to be able to determine how many apples Nthabi is going to get, we're going to take these 2 apples, the 2, you divide by the total, and you times it by the number of apples. Okay, that's how we basically work with ratios if we are sharing, right? Also, for Tabo, you will take that 5 from the ratio, divide it by the total that we got from the ratio, times it by the number of apples that we have in total. So if you take 2 divided by 7, multiply by 35, we can see that, Nthabi is going to get 10 apples. Then, if you take 5 divided by 7, you multiply by 35, we see, Tabo is going to get 25 apples. So we see that at the end of the day, we still have that total of 35 apples. But now, because of this ratio that's given to us, it's just helped us determine how many apples Ntabi saying is going to get and how many apples Tabo is going to get. So that is how we work with ratios when we are sharing. Okay, right? You need to first get what is the total for that ratio. Then from there, take the 2, you divide by the total times by what is the total number? Because then that is going to help you then determine how much each person is getting. Same concept here. Okay. When it comes to these perfumes that are packed in this box, they are telling us that there's a maximum of how many perfumes. We've got 75 perfumes here. 75 in a book. And those 75 perfumes, okay, are in the ratio of 2:5. Okay. There's cylindrical perfumes and there are rectangular perfumes in that box. So before we can even determine the probability of selecting, because now remember here we're calculating probability of selecting a rectangular bottle from the box, we first need to determine how many rectangulars do we have in there, how many cylindrical perfumes do we have in this box. So we see we are still dealing with the sharing ratios. Okay, so what you need to do, you take the 2, you take 2 plus 5, you need to get the total for the ratio. Okay, then from there, remember they said that in 1 month, storage workers packed 75 perfume bottles as cylindrical and rectangular bottles. Okay, so they're just telling us that they packed in the ratio of cylindrical and rectangular. Okay, that's how they have been packed. So the 2 represents the cylindrical, the 5 represents the rectangular. So now, for us to determine how many cylindrical were packed, how many rectangular were packed, what do we just need to do? We are just going to take that 2 divided by 7 multiplied by how many total perfumes were there? 75 perfumes. Okay, so if you say 2 over 7 multiplied by 75, this is just telling us that, okay, I think you're getting a decimal value, but okay, it's fine. It's 21,45, 42, which is 43 cylindrical perfumes. This is for the cylindrical. No, I made a mistake. No wonder it's not making sense. It's not 2:5. No, it's 2:3. I was wondering why it's giving me a decimal. Okay, let's fix that, please. It's 2:3. Okay. Look at the question. It's 2:3, no? Not 2:5. Okay. So it's 2:3. So the 2 represents the cylindrical. The 3 represents the rectangular. Okay. So remember, you get the total. So to get the total, you say 2 plus 3 is equal to 5. Okay, that's the total for our ratio. So to get the cylindrical perfumes, you take 2 divided by 5 multiplied by 75 perfumes. Okay, this is going to give us the cylindrical. Okay, so 2 over 5 multiply 75. You see that you've got 30 cylindrical. Then to get the rectangular, what must we do? Just move it up. Same thing here. Now take the 3 divided by 5 multiplied by 75 perfumes, okay? Which is
45.
45. But remember, we haven't answered the question. They say, what is? We just determined, oh, that means that they've packed 45 rectangular. They've packed 30 cylindrical, which gives us a total of 75 perfumes in that box, okay? Right? Now, remember, when we are calculating probability, okay, remember what you always said. Always write the formula. Probability is equal to favorable outcomes divided by total outcomes. They didn't say determine the probability as a percentage, as a decimal, as a level. So there, you just use whatever you want to do. You can find the percentage, doesn't really matter. They didn't specify. You can even just leave it the way that it is. Okay, right. So here, what's the favorable outcomes? You want to determine the probability of selecting rectangular bottles. Okay, so how many total rectangular bottles do we have? Remember, we said we've got 45 divided by how many total bottles do we have in the box? We said that we've got 75.
75.
So then from there, we are done. Okay, remember, if they say simplified form, you can even simplify it further to 3 over 5. But because they haven't really, specified how you must leave, you can either leave it like this, you can leave it like this, doesn't really matter. But I suggest that just sometimes, if it's possible, if you can simplify it further, just simplify it. Press SD on your calculator. The calculator does the math, simplifies that for you by dividing by the highest common factor for you. So you don't have to stress. Just simplify it, and that's our final answer. Okay. So when it comes to ratios, we use ratios, okay, to share quantities the way that I've done here, or we use ratios to determine an unknown, to determine an unknown. So sometimes when it comes to ratio questions in your exams, because I've noticed that they are assessing on ratios now. It's not just a matter of find the simplified form. They assess. Are you able? So sometimes maybe when it comes to ratios, remember I said it's sharing, right? You need to be able to work with ratios to divide quantities amongst maybe people, even in the context of these perfumes. Or sometimes they can use ratios, or you can use ratios to determine an unknown, right? So let's say, for example, let me give you an example so that you know how to apply this. Let me give you a nice example that I can add to this. I'm just adding this mini sub lesson to this lesson because I think it's important. Just give me a second. I want to give you a nice question. So maybe they say the ratio of cups of flour. So maybe they say the ratio of cups of flour, okay, to, okay, remember 2, I'll just say 2 cups of water is 9:4. Okay, so the ratio of cups of flour to cups of water is 9:4. So 9:4. So it basically means that the cups of flour to cups of water, the ratio that is given is 9:4. Now the question will say, a pizza restaurant makes a quantity of dough using, so they say that maybe the restaurant, okay, makes, okay, a large quantity of dough using 36 cups of flour. How much water should they use? You see now, in this question, we're not sharing in this ratio, but we want to basically use this initial ratio to help us determine unknown in a similar context, right? So remember, we just given that, okay, the ratio of flour ne, to water ne, is 9:4. Then they're telling us now this restaurant makes a large quantity of dough, okay, which is 36 cups of flour. So we've got 36 here now, 36 cups of flour. And you want to determine X. Do you see? So now we're actually now working with ratios to determine how many cups of water will actually be needed. Now, in this situation, okay, when you have to now, work with this ratio, what do you normally do? Now here, what I always do is that I first want to get my ratio in the form of 1 is to something. Okay, I want to first get my ratio in the form of 1 is to something. Okay, then from there, you ask yourself, once it's in the form of 1 is to something, what did they do to move from this value to that value? Okay, what they did here, you also need to do there. Right, so that's basically what we do. So let's do that first. We want to get the ratio into 1 is to something. So I'm going to divide by 9. I'm going to divide by 9. So I'm going to be left with the ratio of 1:4/9. Ne? Then you still have that 36:, we want to determine this X here. Then I ask myself, how did they move from 1 to 36? They multiplied by 36. What you do on the left, you also need to do on the right. So that means I'm also going to multiply this number by 36. So to get the value of this unknown here, X, I'm just going to say, okay, to get my X, I'm going to just say 4/9, sorry guys, I'm tired, multiplied by 36 will give us this value, how much water will they need for 36 cups of flour. So if you take 4/9, multiply by 36, you'll see that, okay, they actually need 16 cups of water. Okay, so very, very important. Ratios, we can use ratios for sharing, but when it comes to sharing, you add them together, you get the total. Then you take the number divided by the total for the ratio, multiplied by how much you have in total in a box or whatever is being shared amongst people. Or you can use ratios to help you determine unknowns. So if they give you a ratio, they say the ratio of cement to sand is 3:5. If you've got 5 bags of cement, how many? Okay, yeah, or even if they say the ratio of cement and sand, the ratio of cement to sand, right, is 15:, I'm just random values, is to 7. Ne? Then how many bags of cement will I need if I've got 20 let's just say 20 meters cubed of sand? You see, so same thing here. You first need to get this in the form of 1 is to something. So I'll divide by 15, divided by 15. Okay. Then from there, you'll just have 1:7/15. Then, right, it will be X:20. Then you ask yourself, what did I do here to get to 20? Okay, sorry, guys. This is a bad example. Let's do this. Ratio of, let me fix this. Ratio of, maybe they say if you've got 20 bags of cement, how much sand will you need? How much sand will you need? X. Okay, so same thing there. 15 divided by 15 is 1. 7 divided by 15, 7/15. I hope we are following still. Then it's 20:X. We are trying to determine how many cubic meters of sand will we need. Then here, what did you do to get to there? You multiply by 20. What must you do here? That means you multiply by 20. So it will be 7/15 multiplied by 20. That's how much sand you will need. Okay, so you need to think of it also in this way. Okay, they really, 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 really like these ratio questions, using ratios to help you determine unknowns or to help you share quantities. Okay, does it make sense, Mara, what I've just explained here when it comes to ratios? or I've confused you even more?
Yeah, it makes sense.
Okay. Right. I think we are done with question 5.2.2. Question 5.2.3, they say Pam claims that if the volume of one rectangular bottle rounded off to the nearest whole number, then the capacity of the rectangular bottle or cylindrical bottle would be the same. Okay. The volume of the rectangular bottle is 172 centimeters cubed, and then verify with the necessary calculations whether Pam's claim is valid or not. What is Pam saying, you guys? What did she say? Pam, what is Pam saying? Any ideas? Anyway, so Pam is basically saying, or we are basically told that the volume of the rectangular bottle, okay, let me just do it here. The volume of the rectangular bottle is equal to 172 centimeters cubed. Okay, 172 centimeters cubed. Now, what Pam is basically saying, she's claiming that the volume of the rectangular bottle rounded off to the nearest whole number, then the capacity of the rectangular bottle or the cylindrical bottle would be the same. So they're saying that if you were to round off the rectangular bottle, so you basically need to, this is the rectangular bottle, the volume of it rounded off to the nearest, or the capacity, sorry guys, the capacity of the rectangular bottle rounded off to the nearest whole number is basically the same as the capacity of the cylindrical bottle rounded off to the nearest whole number. That's basically what this person is saying. Okay, that if you basically find out what the capacity of the rectangular bottle is and you round it off to the nearest whole number, it would be the same as finding or the capacity of the cylindrical bottle. That's basically what this person is claiming. Okay, so for us to be able to verify this claim or this statement, we first need to start off by calculating what is the capacity of the cylindrical bottle. So before we can even get to capacity, you can't just jump to capacity. Yeah? We first need to find what is the volume of the cylindrical bottle. Because he's claiming that if you were to round off whatever you get from the capacity of the cylindrical bottle, it will be the same as the volume or the capacity of the rectangular box. Okay, so let's start. We need to first find what is the volume of the cylindrical. They gave us the formula there. Pi, please, it's not pi, it's 3,142. They've actually given us what we need to use for our pi. 3,142 multiplied by what is the radius of the cylindrical? It's 4 centimeters, all squared, multiplied by what is the height? 5 centimeters. So 3,142 multiplied by 4 multiplied by 5. 4 squared multiplied by 5. You can already see that these things are not the same, but let's continue. 251, comma 36 centimeters. Right? So he claims that if the volume of the rectangular box rounded off to the nearest whole number, then the capacity of the rectangular bottle or cylindrical bottle will be the same. You see, this person is just claiming that the capacity of the cylindrical bottle and the rectangular bottles are the same. That's basically what they're claiming there. Okay, so if you've already calculated what the volume of the cylindrical bottle is, right, we want to determine ini capacity. Okay, remember, I told you, sometimes they're not going to give you how you convert from volume to capacity. You need to know these formulas off by heart. I'm sure you can see that they didn't give us here. You see, they didn't give us those formulas. Remember, so you need to remember that, remember 1 meters cubed is equal to 1,000 liters. They like not giving us. Or 1,000 centimeters cubed is equal to 1 liter. So we can already see that we're going to be using this one here to help us to convert these volumes into capacities. Okay, how much water they can hold. So if I just take, I'm just dealing with the rectangular for now. And when I take the 172 centimeters cubed multiplied by, I want liters, or let me just say divide by what I have, because I want to cancel out the centimeters cubed, multiply by what I want. Get my answer? Same here. 2, 5, you can already see that they're not the same, honestly speaking. Centimeters cubed divided by 1,000 centimeters cubed multiplied by 1 liter. Right? Remember, let's just follow it. Let's follow the procedure. 1,000. Okay, you will see that you get 0.172 liters. Same here. If you take 251.36 divided by 1,000, you'll get 0.25136 liters. He said, if you take these capacities, round it off to the nearest whole number. But now, hectic stuff. They're actually all going to be the same. Let me see. Volume of one rectangular bottle. Round it off to the nearest whole number. Then the capacity of the rectangular bottle would be the same. Oh, okay. If we take the volume, right, let's see. Remember, when you take the volume of the rectangular, remember they gave you that this volume of the rectangular, let me just quickly check, it's 7 times 3.5 times 7 is equal to, all right, look. Sorry, guys. So the volume, you'll check, ne? But you'll check how they got to this 172, ne? The volume is actually equal to 171.5 centimeters cubed. This is just the value that they got after they've rounded off to the nearest whole number. Remember, if you round it off to the nearest whole number, okay, you look at the 5, it changes that, it becomes the 2. So she's claiming that if the volume of one rectangular bottle rounded off to the nearest whole number, so it's this, okay, rounded off to the nearest whole number, then the capacity of the rectangular bottle or cylindrical bottle would be the same. Are their capacities the same? Remember, I've just used the value that I got when I've rounded it off to the nearest. You see, this is just the capacity, ne, that I'm working with. I mean, the volume that I'm working with after rounding it off to the nearest whole number, right? And then from there, I just calculated the capacity. And then from here, I took the volume of the cylindrical bottle. Okay, I got the volume. And then I found the capacity. But you can see that even if I rounded off the volume of this rectangular bottle to the nearest whole number, it doesn't give us the same capacity. Do you see? They're completely different. Because the capacity of the one will be 0.172 liters. The capacity of the other will be 0.25136 liters. So the capacities are not the same, even when you've rounded it off to the nearest whole number. So we can already see that the statement is, okay, so we can see that that statement is invalid. Okay, so this question is a bit confusing. It really just wanted us to just, look at it properly, read it properly. They're just saying, you find the volume of the rectangular box. Ne? You find the volume of the rectangular box. Ne? Then, after finding that volume that you'll check for yourself. If you calculate the volume of the rectangular perfume bottle, you'll see that it's 171.5 centimeters cubed. That is the volume. But now, this person is saying if you were to round off this volume to the nearest whole number. So if you look at this 5 and you round off to the nearest whole number, it changes it and it becomes 172 centimeters cubed. And this person is saying that now, when you work with that rounded off value of 172 centimeters cubed, and you find the capacity of it, and you also find the capacity of the cylindrical bottle, their capacities will be the same. So we can see that they are not the same, okay? Because this one is 0.172 and this one 0.251. Okay, therefore the statement is invalid, right? So yeah, I think it was a bit confusing, Yana, how they phrased it. Okay, just needed us to just read it, Yana, once or twice, and then yeah, makes sense, nah? Does it make sense what I've just explained? Or does anyone want me to repeat the explanation again?
Yes, it makes sense.
Oh, okay. Right. And then I think that's it, guys, right? That's that for the paper. Okay, then if you also want to just quickly go through this last question.
That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.